Hello, welcome to today's lesson. Today we're going to look at volumes of pyramids and cones, and in order to do that and understand where these formulas come from, I'm starting off with a box shape and then I'm going to look at a cylinder. So let's look at the box shape first. Now to get the volume of a box, I think most people would agree, not too bad. You take the length times the width, and then you times that by the height. Okay. Another way of thinking about that, though, length times width, is kind of like saying getting the area of the bottom, okay, of this rectangular bottom, is the area of the base. Okay, so that's how I'm kind of thinking of length times width. And then it's kind of like I'm going to stack those up. How many of these rectangles I can fill in the box. So I'm going to times that by the height. Okay. So if we think of it that way, that's a pretty good way to think of the volume of a box. And I'm going to use exactly the same approach down here for the volume of a cylinder. I'm going to think of the area of the circle, which is the base. So think of it as a plate. And the area of a circle is pi times its radius squared. And then I'm going to kind of stack the plates to fill the cylinder. So times that by the height. So that's my formulas for the volume of a box and volume of a cylinder. Now here's how these relate to pyramids and cones. So I'm going to try and do this. Maybe I'll change colors on this. See if this works well. Let's see, color. Let's change to blue and see. So I'm going to draw a pyramid inside the box. It's going to have the same base, the same length and width. So each of these little corners basically are going to go up to this middle point on the top. So if I do that, I'm kind of constructing a pyramid inside the box. Okay, so this line here didn't show up very well, but let me see if I can show you exactly where this pyramid is. So we got this part here is one side of the pyramid, and then here's the other side of the pyramid, and so on. Okay, so there's our pyramid. It has a length and a width identical to the box, and in fact, the pyramid's got the same height as the box. So how do I get the volume of that pyramid? Well, it's actually really easy because it's so related to the box. You just take the same volume of the box. Okay, so length times width times height, and you divide that by 3. And there it is. There's our pyramid. That's the volume of our pyramid. Okay, as long as you think of it as fitting perfectly inside the box. Now if I go down here and I decide to do basically the same thing, except because it's got a circular base, it's not going to be a pyramid, it's going to be a cone. See, I'm going to take this point on the top and run that down. So what I'm getting here is I've got this little cone here inside of the cylinder. Got exactly the same base radius and the same height as the cylinder. Now you could probably guess what the formula is for the cone. It's the same as the volume of the cylinder divided by 3, just like it was up here for the pyramid. So now I've got the two formulas for pyramids and cones, and you can see how they relate to cylinders and boxes. So why don't we do one example here. Let's clear off the screen and see how it's actually used. Okay, so let's just keep working in blue here. Maybe somebody says we've got a cylinder. So I'm going to draw a cylinder here. Sorry, not a cylinder, a cone. So we've got this cone here. And let's say we know what the radius or actually we don't know the radius, let's say, but we know the height. Okay, so somebody comes along and says the height is 10 centimeters. And I don't know the radius, but I do know the slant height is 14 centimeters. And then the question is, find the volume of the cone. All right. Okay, let's have a look at the formula. So for a cone, it's the same as a cylinder divided by 3. Now, often you'll see it written like this. 1/3 pi times radius squared times height, or the volume of a cylinder. Okay, so I'm ready to use the formula to get the volume. So I got 1/3 times the pi, and then, oops, I don't know the radius. I do know the height, however, is 10. So how do I continue this question? Well, in order to find the radius, r, I'm going to have to use Pythagoras' theorem. So I'm going to call that r. I'm going to set up Pythagoras' theorem with this little triangle. So there's the hypotenuse squared equals the sum of the squares of the other two sides. And I'm just going to do a little bit of algebra, square out these numbers. And then I'm going to subtract 100 from both sides. So that leaves me with 96. And to get r, I'm going to square root that. So it's the square root of 96. I could just leave it like that if I wanted, leave it as an exact number. And that means I'm going to put in here, for the radius, square root of 96. Now this is kind of neat. If you square root a number, but you also square the number, it actually undoes that. So I could do this on my calculator, make it a little bit easier. Just go 1 divided by 3, times it by pi, times it by 96. Because the square root of 96, when squared, will bring me back to 96 times 10. Now if I crunch that through on my calculator, I got 1005.31, and the units here would be centimeters cubed because we're talking about volume. And that's pretty much the end of that question, so I will stop and we'll catch you later.